what is isotope? Let's define what is isotope first. Okay, isotopes are atoms of the same element. Okay, are atoms of the same element. Okay, let's slowly follow this definition first. Later we're gonna find out what it means exactly. Okay, same element with the same proton number. They have the same proton number. The same proton number. Remember what is proton number? Proton number indicates the number of protons. Okay, but different nucleon number. But different nucleon number. Alright, let's revise again what it means to have a chemical symbol, and you have A here and Z here. So this A is nucleon number, and this nucleon number consists of proton and neutron. Okay, because collectively they are called nucleons. Here indicates the number of proton. Alright, in a neutral atom it also means the number of electrons. Alright, so isotope occur because when scientists they discovered a certain substance, they exist together and they have the same proton number but different neutron number. Alright, so let's investigate first. I'll give you an example. Let's say you have this hydrogen 1. Okay, this is called hydrogen 1 and the special name for it is protium. Okay, so most hydrogen atoms are like this. They say it has one proton and one electron. One proton, one electron. So this majority percentage being found. Okay, could be 98%, something like that. Okay, you can check the proper values later. And they say 15 in every 100,000 are like this. You know, they have this 2p and 1e. No, sorry, they have p and n. This one they have 1p and 1n. This one, the characteristic is there's no neutron. Alright, so this is a 1,1H, while this is 2,1H, and this is what we call a deuterium. This is what they discovered. They discovered this in a small amount. It still has the same number of proton, p and p, but this one has extra neutron. And the third type, they discovered that it has 1p and 2n, and one electron, again the same thing. And they say a very tiny number was discovered. This type of hydrogen, a very tiny number of this type with two neutrons called tritium are discovered. Very tiny, maybe less than 1% or 0.01%. So this is called tritium, and it has the formula of 3,1. Okay, so this is due to the discovery, and they measure the percentage of the different isotope, but they found out that they have the same number of proton. So the same number of proton also indicates the same number of electrons. So we can say that since they have the same number of proton, therefore they have same number of electron. And we have learned before this that the number of electron actually determine the chemical characteristics. Alright? But what's so different about these three isotopes? These three isotopes, they are different in terms of their mass. Do you still remember that most of the mass are actually concentrated in the nucleus? So you see the first one, the mass is very little. Let's use red to indicate this. See? The mass here compared with this mass here and compared with this mass here. This is like 1 and this is like 2 because 1 plus 1. because we know the mass of neutron is almost the same as the mass of the proton, and here is almost 3. Okay, so they differ from each other in terms of their physical characteristics. Okay, isotopes differ in terms of their physical characteristics. Isotope differ in terms of their physical characteristic. Let's imagine 3 person. Alright, so Mr. Protium is very thin. Alright, so you have this, and Mr. Deuterium is slightly plump, more plump. Okay, then you have tritium, the fattest of all, like myself. Okay, so we have different characteristics in terms of the mass. Okay, what else about physical characteristics? Characteristics, when you talk about physical characteristics, you can also talk about melting point, boiling point, mass. When you talk about mass, you're also talking about density and many other physical characteristics. See? So they differ because of their different number of nucleon. Nucleon number is different because this one is H1, this H2 heavier, and this is H3 much heavier. Okay, so alternatively, we can also define isotope in this way. Alternatively, we can define isotope as isotopes are atoms of an element with the same number of proton but different number of neutron. Okay, but different numbers of neutron. Okay, so what we can say is they are similar in terms of chemical characteristics, but they differ from each other by physical characteristics. So isotope has many usage in agriculture, medicine, technology, and all that. So more example of isotope would be something like this. You have carbon 12, you have carbon 13, you also have carbon 14. Chlorine, you have chlorine 35, and you have the chlorine 37. Chlorine 35, chlorine 37. Okay. And some isotope, they are not stable. Unstable isotope, we call them radioisotope. It has nothing to do with the radio that you listen to every day, but radio means radiating. Because if they are unstable, their nucleus will radiate some smaller particles out of the nucleus, and the nucleus can transform itself into a more stable isotope. Okay, so all these radioisotopes are even more useful in the fields of medicine. Okay, to kill some tumors or to eliminate certain things. Okay, you can find out more from the usage of the isotopes. Alright, so example of unstable isotope, radioisotope is tritium. Tritium is very unstable. Okay, so sooner or later the nucleus will break up. Sooner or later the nucleus will break up and it will give out some radiation. Alright, you can find out more about this in physics final chapter of Form 5 SPM. Alright.